Good morning, class 9 students. Today we are starting a new chapter. The name of the chapter is polynomials. So in the previous chapter we have learned the number systems. How important topic in the previous chapter was rationalization and laws of exponents. Okay, so you should try some more questions on rationalization and uh, I'll just give you just some hint of what you should be practicing on. Suppose somebody says what is 2 minus root 3 plus something like this, okay, plus 1 upon root 3 minus 2 root 3 minus root 4, something like this, okay. You should be able to solve such questions because remember this has to be multiplied by 2 plus root 3 in the numerator and denominator, and this has to be multiplied by root 3 plus 4. So why we are multiplying? If it is minus, we are multiplying by plus. If it is minus, we are multiplying with plus. Suppose if the question is like root 5 plus root 6, then you will multiply it by what? Root 5 minus root 6 in the numerator and denominator. So this kind of question you should be practicing a lot, and laws of exponents also. The type of question which I gave you to compare also, like suppose somebody asks you what is cube root of 25, you should know that we can write this as cube root of 5 square, and this we can write as 5 to the power 2 by 3. This kind of comparison, this kind of writing radicals into exponential form is very important because laws of exponents can be used here. Here you cannot directly use laws of exponents. So this kind of calculation, if you are able to do, then it will help you a lot in a lot of easy questions or difficult questions also, for that matter. For example, I gave you whether this is greater or square root of say 10. Now square root of 10 is what? 10 to the power half. Okay, this is 10 to the power half, and this is 5 to the power 2 by 3. So 5 to the power 2 by 3 and 10 to the power half. So somebody asks you which one is greater. Now you cannot directly compare. So you need some numerator denominator same, just like you compare two denominators. So this time in exponents you do that comparison. Multiply this by say 3 in the numerator and 3 in the denominator, or 2 multiply by 2. This will become 6. Okay, we are taking the LCM of 2 and 3, that is 6. So 10 half, we are multiplying by 3 here and 3 here. So this is 5 to the power 4 by 6 and 10 to the power 3 by 6. So now this can be written as 6th root of 5 to the power 4, and this is 6th root of 10 cube, right? 6th root of 5 to the power 4 is 5 into 5, 25, 25 625, 625, and 6th root of 10 cube is 1000. So this is definitely greater. So you should know how to solve this kind of questions, okay? Now again, law of exponents are important with respect to this chapter also, polynomial. So we'll start the definition. Any algebraic expression like x square plus 1 upon x is not a polynomial. When does it become a polynomial? It becomes a polynomial when exponent, that is power. We just written exponent, no? Exponent or power of the variable is should be non-negative integer. What is non-negative integer? So this is very important. Okay. What is the meaning of non-negative integer? Means that suppose if I look at the power of this. Now see, laws of exponents are here so important because this can be written as x to the power minus 1. This one. So this minus 1 is an integer, but it is not. It is negative. It is not non-negative. So we need positive integer, or it can be 0 also. That is why we are writing non-negative integer. So how it is in 0 or positive? Let us check. X square. What is the exponent? 2. So it is a polynomial. 1 upon x written as x to the power minus 1. Not a polynomial. 2. 2 is a constant. It's called a constant polynomial. Now where is the variable? Somebody will say there is no variable here. How can we say about polynomial or not? You are saying non-negative power should be non-negative of the variable. No variable. Where you can create a variable like this. Another law of exponent is x to the power 0 is 1. So this is same as 2 into 1, that is same as 2. Right? So this power is 0, so this is also a polynomial. So any real number that you have studied, 2, half, root 2, any real number, these are all polynomials. They are all polynomials, okay, and they are called constant polynomial. They are called, or they are all polynomials. They are called constant polynomials. Constant polynomials. Okay. Because they don't have variable, we have to create variable and we'll write x to the power 0. But remember, root x, is it a polynomial? Now there is already a variable. Root 2 is a polynomial, but root x is not a polynomial. Let's see why. Because x to the power half. Right now I said root sign can be written as x to the power half. Half is not an integer, it is a fraction. So this is not a polynomial. X to the power half is not a polynomial. Okay, so similarly you can do a lot of questions like this. 1 upon x square, is it a polynomial? No, because x to the power minus 2 is also not, this is negative. So you cannot have a negative power, you cannot have a fraction power. The power should be positive, 0, and it should be integer. Power should be positive, 0, and it should be integer, then only it is a polynomial. Okay, and what, then you will say why root 2 is a polynomial? Because root 2 is a number, it is, there is no variable here. So where is the variable? Variable you will have to create, x to the power 0, then you will write root 2 into 1, that is root 2. So this is a polynomial, but root x is not a polynomial. Okay, pi is also a polynomial. All real numbers are polynomial, they are called constant polynomial, but whenever variable has come, you have to check its power. Okay, now polynomial in one variable and two variables, like that. This is a polynomial in one variable because the variable is x. This is a also a polynomial, but it is in two variables. So in your book, in the first exercise is asking polynomial in one variable, so you will tick for this, but this you can write it is in two variables. Okay, suppose somebody asks you, and you have to check every term, even if in one term the power is negative or fraction, you will cut it. That is, you will say it's not a polynomial. Like here, x square is a polynomial, but somebody says root x. As soon as you get plus root x, you will say this is not a polynomial because this is like x square, x to the power half. Even if one term you are getting fraction, then you will say it is not a polynomial. Okay. Another thing is monomial, binomial, trinomials. You already know. Multinomials. Okay. Monomial is single term like 1, 2, x square, right? Binomials are having two terms like x plus y, x square plus x, 2x plus y, okay, x plus x cube, or we can even have separation by negative sign. Trinomials are three terms like x plus y plus z, x plus 2x square plus 3x cube, like that. And sometimes you have to be very careful. If you can add, then you will become a monomial only. Somebody says, what is x plus 2x? Is it a binomial? Yes, it's not a binomial, it's a monomial because this is 3x, can be added. So it can be added, it's a monomial. If you can reduce, like somebody says 2 plus x, can we write 2x? No, not at all. This is still a binomial. Okay, somebody says what is 2 plus 3x plus 5x? It's a trinomial. No, it's a binomial because this 2 plus 8x. So you should know what are monomial means one term, binomial means two terms, and trinomial three terms, and after that you write multinomials. Okay, and they are all called polynomials. Now don't write after that polynomials. So in previous classes you have studied polynomials means having a lot of terms. So there they will say this is also a polynomial. No, now this is not a polynomial. In our definition, we have already studied that x cannot be negative. Okay, the power of x cannot be negative. Therefore, this is not a polynomial. So you will, for multiple terms, you will write multinomial. So monomial means mono means one, bi means two. So binomial, two term. Tri means three, and then there are four terms. Also we have a name, and that is quadranomial. Quadranomial. Sometimes for 5 we can write pentanomial, 6 hexanomial, heptanomial, octanomial, nanonomial, decanomial, and then multinomials. Okay, so this is all about types. And then you have degree. Degree is called the highest power of the variable. Highest power of the variable. Highest power of the variable is called the degree. Okay. Highest power of the variable is called degree of the, what is called degree of the polynomial. So you can have, if degree is 0, you will call it constant. Like all numbers like root 2, pi, half, -3, 1, 2, these are called constant polynomial because there is no variable, so its power is 0. Okay. And if the power is 1, it is called, power is 1, it is called what? Linear. Power is 1, it is called linear polynomial. X to the power 1. Okay, x, 2x, 3x, these are all linear polynomials because their power is 1. Even y, z, these are also linear polynomials. If the power is 2, then it is called quadratic polynomial. Okay. Quadratic polynomial, power is 2, you write x square, 2x square, okay, x square plus y square. These are all power 2, so these are quadratic polynomial. Power is 2 of the variable. Okay. Here the power is 1 of the variable. So, and one more is there, cubic. So cubic you will write, okay, what is the cubic? X cube, power is 3, y cube, like that. Okay, the power is 3. Then there is biquadratic. Biquadratic is power is 4, and so on. After that we don't name, you just write the degree. That suppose what is the degree of this? X to the power 5, x to the power 100, the degree is 100. Okay, x to the power 101 plus x to the power 205, the highest power you have to write. So x 205 is the degree here. Okay, so this way you should, I'll give you 2.1 for trying, and then we'll see what problems you have got in 2.1, right? See you in the next one.